Hello everyone. Today I am facing a problem in the EGCS operating monitoring panel and main control panel. The problem was the load of the number 4 DG is not showing in the panel. So I can show that. See, now number 4 DG is not in running condition. You can find number 1 DG load is showing in the panel. It was around 1400 kilowatts. But while we are starting the number 4 generator and we are taking the load, we cannot able to get the load. And I troubleshooted it and I found the problem was with the analog input cards in the MCP of the EGCS panel. So how I did the troubleshooting and how I will declare that AI card is the problem in the MCP panel, and I'm going to discuss regarding this in this video. So first, what I did, I opened the ECC. From ECC the data is transmitting through 4 to 20 milliamps from the analog output card. AAO means analog output, and the 02 is the number of the card. So these two wires are regarding with the number 4 DG. The number 4 DG load will be transmitted as a 0 to 4 milliamps from ECC to the MCP panel of the EGCS. So I checked the amps here. Here we are getting the correct value of the amps according to the kilowatts. At the end of the video I will show how we can calculate the load depend upon 4 to 20 milliamps. So then I read the diagram. In the MCP panel we have a analog input cards. So A02, in A02 we are getting totally number 1, number 2 and number 3 generator output in the channel number 6. So next card is AI03. Here we are getting the number 4 DG output and the EGCS exhaust gas temperature inlet and the exhaust gas temperature outlet. So now I am going to check that. Before that I want to show you something. Here in the AI cards we can change the dip switch. So the value what we are measuring we can declare it with the dip switches. See here it was a 4 to 20 milliamps between the load of 0 to 4785 kilowatts. So now number 4 DG is off load. So if I measure the amps of the number 4 DG, I should get 4 milliamps. Let go and we will measure in the MCP panel of the EGCS. So these are the discharge and the wash water sensor unit of the EGCS. Here we are having this main control panel for EGCS. So inside we have these cards and we have the control unit also for this. So here you can find the AI and AO cards. So this is the AI card. See, A03. In this we are having problem in CN6. So we have a problem in channel number 3. So here I am going to check the amperage of the number 4 generator between these two wires. So I am going to take out the wires and I will measure. So I take out the one lead outside and keep the multimeter in a milliamps, because this is a 4 to 20 milliamps, so I keep it in the milliamps and I keep one lead there and one lead I connected with the red probe. Now you can find it is around 3.99 milliamps, approximately equal to 4 milliamps. So now DG4 is in offload, so we are getting exact amps 4 milliamps. That means we are getting the data. So the data is not processing by this AI card, and it was not sending to the human machine interface display unit. So I will measure the number one DG load also, and I will show you. So now I am connecting to the number one DG load. You can find out how much amps I am getting. I am getting around 8.81 milliamps. Okay, 8.81 milliamps. So those terminals are doing their duties correctly, like they are taking the data and they are processing it, and they are given to the PCU. From PCU it was given to the human machine interface display. So now I will show, like 4 to 20 milliamps, how it will, what is the relationship between 4 to 20 milliamps and 0 to 4785 kilowatt. So for conversion, the difference between 4 to 20 milliamps was 16. So divide the 4785 kilowatt by 16. So for each increase in the 1 milliamps, we will get a kilowatt of 299.06. So we are getting around 8.81 milliamps. So we multiply this with 299. So see, now the load should be 2631, and my generator load was around 2631. Actually now just they stopped the pump, that's why the load get reduced. So in this AI cards I need to show you some interesting things, like here we can have a dip switches and the selector switches. We can adjust the selector switches so that we can feed this AI cards to measure what they want, what type of value they are going to measure. Like if you keep in, so these are the terminals, like A, B, C, D. We have 4 terminals. If we want to measure a 4 to 20 milliamps, we should connect in number B and number D terminals. If we are measuring the resistive type using the PT100, we should connect between B, C, D for 3 terminal PT100 and B and D for 2 terminal PT100. So here you can find the selector switches, that yellow one with the arrows. If you keep in a 0 position, it will convert the value of PT100, and it was a 2-leg PT100. Between the range of the PT100 should be 0 to 200 degrees Celsius, and one 3-leg PT100 same range 0 to 200, and 2 0 to 800 degrees Celsius with the leg of 2, and 3 0 to 800 degrees Celsius with a leg of 3. And if you keep the selector switch in 4, it will measure 4 to 20 milliamps. Now we are going to measure the 4 to 20 milliamps. So keep the selector switch in number 4. Thank you all.